That would be funny. Hey, if they want to learn about stats, that's cool.
Yeah,
We'll teach one another. We'll fulfill the learning model.
that's right.
That's pretty good. I like that. All right. Okay.
So the first question that was there was, what notation is used to denote the probability of an event occurring? That was straight from the reading, yeah.
Yeah. P in parentheses X.
Yep. Times X, yep.
Pretty cool.
Please state and describe the 3 rules of probability. The one that I got that was pretty straightforward was the sum must equal to like 1 to like 100%. So like statistically speaking, it has to occur, or like something. It's like when you flip a coin, something has to occur. Either it's heads or it's tails. It's a 50-50 chance, but they add up to 100 or 1. Yeah.
Makes sense.
Did you get another one?
Yeah, I don't know how to phrase it though. Let me just I know exactly what they're talking about, and it makes sense in my head, but it's hard for me to like
the probability of P is between 0 and 1, meaning
yeah, exactly.
It can't be 0, meaning that like it has to be able to happen. It's like when you flip a coin again.
Yeah.
It's like it's a 50-50 chance. So the probability of P happening, so we'll assign like heads to P.
Hey, what about a coin flipping just right on its side and sitting on its side?
That's probably true. It's probably like 49.999%.
Yeah.
0.0001%. Yeah.
That would be funny. Yeah, something like that. I don't know.
Then the probability that it won't occur is 1 minus the probability of it occurring, which is pretty straightforward.
Yeah, it'd be like 0.0001 or whatever that we, or 2 or whatever we agreed on. Anyways, yeah, and then there's another one. Hold on, I'm trying to get back to my notes here. Rules of probability. Right here. Okay. The other one is the complement rule. It says the probability that an event X will not occur. Oh, we already just said that one. So it's the 1 minus the probability that it'll occur. So
yeah.
Very good.
What does it mean to be random? I put that everything had an equal chance of being like selected. So like, yeah, it just needs to have equal probabilities between all of the variables.
Yeah. Like if you were to use the coin example, you know, it would be 50% heads, 50% tails. Something like that.
Yeah. And then the side thing doesn't ever occur, so.
Yeah. I mean, I've never seen it occur, but apparently, I mean, some people probably claim that it has, so who knows? I guess it depends on how high you're trying to flip the coin.
Yeah, maybe.
Who knows? Anyways, let's see, what else do we have? What does the phrase discrete random variable mean? I'm actually looking at the section right now, so you think I'd be able to come up with the answer right away?
I put that it was really confusing in the reading, I found. So go ahead.
I was just going to read the reading thing and try to rephrase it, but it says the phrase discrete random variable has a very specific meaning. It's a variable, a variable is something that varies, of course, and a variable is random if its values follow a specific distribution over the long run. The true meaning of the word discrete is too technical for this course. Roughly speaking, a random variable is discrete if its values could be listed in principle given enough time. So like if you flip a coin 100 times, you know, maybe it'll end up pretty close towards 50-50, you know, maybe like heads was 52, tails 48 or something like that.
I'm gonna need some Kleenex for these guys, 1 second.
Okay. I'm guessing that would follow along.
What I put was that variables can only take up a countable number of values, meaning that it could only be like it can't be like 0.7. It'd have to be like 1, 2, 3, 4, 5. And it has to sum up to equal like 1, like you were saying. So like if you flipped a coin 1,000 times and it was 50-50, like 500 heads, 500 tails. it sums up to the 1 when you divide it by the 1,000.
You couldn't have like 50 and 49, or you'd have to go up for the full 100 if you did it 100 times or something, or
Yeah.
whatever. So yeah, cool.
All right, and each sided die. Oh, sorry. Has a probability of rolling 1, 2, 3, 4, 5 through 8. Calculate the probability of rolling a number greater than 5.
So 6, 7, and 8, right?
Yeah, so it's 3 over 8. That's what I got.
Yeah.
Yeah, that is what it is.
And then calculate the probability of not getting a number greater than 5.
Well,
I did one of the rules, the probability it won't occur, 1 minus p. So we calculated p to be 3 over 8. So if you
so
do
it'd be
1,
5.
yeah, 5 over 8.
Yep, makes sense. That makes sense. Okay, well that was easy enough. Let's
Onward.
do the group quiz.
Yeah, onward and upward. Eh?
Any questions, by the way? I mean,
No. No,
Okay.
it let me do the individual preparation
Okay.
this week.
Sweet.
So it's a little touch and go. It's like it's either my stats class is having problems or my econ class is having problems. But it was funny, brother Bennett, he like responded to my email because I was like, hey, I was reaching out to him, and
Yeah.
he just said that it was quote unquote confusing. My explanation was confusing, but he opened it up for me anyways. And I was like, not trying to swindle you, brother Bennett. I just want to do well.
That's funny.
I was like, okay.
Yeah. Well, all right. So what do we got here? Human blood can be classified into one of 4 basic types: O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. The blood types and the proportions given in the table above define a probability distribution. Wouldn't that be true?
Probability distribution. I didn't remember that.
Yeah, I don't remember it.
Let's see. Probabilities follow patterns called probability distributions, or distributions for short. There are 3 rules that a probability distribution must follow. Basically, it says probabilities cannot be negative. Probabilities cannot be larger than 100%. And the probabilities...
Yeah, it has to sum to 1, so this sums to 1.
Exactly.
Yep.
So I said true.
Okay.
Okay. What is the probability that a randomly selected person in the United States has type O blood?
45%.
Yeah.
So you just converted into the the decimal into the percentage, and you got it.
Yeah, so it's
Well, it's the
0.45.
Yeah.
Oh, you will have to do the 0.45. Oh, so you
Yeah,
just-
0.45.
Yeah.
What is the probability that a randomly selected person will not have type O blood? So it's just 1 minus 0.45, so 0.55.
Yep.
Okay. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder patient. If the dogs guess at random, what is the probability they will correctly identify? It's 1 in 7. But he
Isn't
has
it
to
1?
be... Huh?
Yeah, 7 balls. Yep.
So it would be 0.143.
Yep. Combined total of 54 trials, the dogs correctly identified the specimen of the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is appropriate? This provides strong evidence that dogs can detect bladder cancer, or there's little evidence that dogs can predict bladder cancer.
Well, I mean, to compare it to baseball, though, if the batting average here would be .407, which really isn't that good. But I don't know. I mean, it's
Based
not
on
really
the
evidence.
paragraph, doesn't it strongly suggest that they can detect it based on how the paragraph is phrased?
Well, the paragraph is phrased that way. I'm just looking at the number 54.
Oh.
They only got 22 out of 54. But I mean, actually, take the probability though. In each of those tests, they're set up the same as what it says there in the next two questions. So without overcomplicating it, in each 54 trials, they only had a 1 in 7 chance of picking the correct specimens. So I guess it provides strong evidence that dogs can detect bladder cancer, right?
Yeah, I think it's strong evidence.
Okay.
So that's pretty good. All right, fine. M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of colors in a bag of plain M&Ms is given in the following table. If you reach into a bag of plain M&Ms, what is the probability of drawing a red colored candy? 0.13.
Okay.
Right?
Oh, I don't think so.
No?
Because the green's taken out.
Oh, do they not add up to 100?
No, they don't. So I think it's 18%, 18.3%. The way I got that was I took 13 and divided it by all of them. Or wait, I didn't divide it by all of them. One more.
Because if I add up all of them right now, it adds up to 0.84, which means green would be 0.16.
Yeah, but we're taking green out of the equation. So I think it's 15.4%.
Oh, I see what you mean. I see
It's
what you mean.
It's what?
0.13 divided by the
'Cause
remaining total.
Okay, 0.13 divided by the total of all colors, including 0.13,
Yes.
Yeah.
Yeah, that makes sense.
and you're getting 0.54 is what you said?
Yeah, 0.15.
0.155
Yeah,
or 0.11 rounded 2 decimal places.
yeah.
Yeah, so 1.16. Right? Because if you take the 7,
Yeah,
makes it a
0.6.
1.55, and then 1.6. And
Okay.
then I already said that it's 0.16 for green.
So those two answers were 0.16 on both?
Well, yeah, because they don't add up to 100 without green. And so if you just add up what they currently are, they all add up to 0.84. And so you
Okay.
take the remainder to make it 1, and it's just 1 minus 0.84 makes it 0.16. I mean, did I
Okay.
do that right? I don't know. Somebody
Yeah, I
check
think
me.
so.
It sounds too simple to be like, this sounds like super simple, and I hope I'm not doing something wrong.
Well, so when it says what is the probability that a randomly selected candy is green, if they took green out, is it 0?
If green's out, then it would be 0.
So, okay. So, like, on question 9, is that 0.16 again, like we were talking about, or is it 0? I'm not sure.
0.16 would be in there, like, so I said, I just did 1 minus, and then I added up brown, yellow, red, blue, and orange, and it was 0.84, so it came out to 0.16.
Is
I
that
think
question 8?
that's question 9.
Okay, and then question 8 was
Is about drawing a red color candy.
right. What was that answer?
So you had to take the 0.13 and divide it by 0.84 as if the 0.84 were the 100% or the 1. Does that make
Okay.
sense? Because like all the numbers have to add up to 100%, and if green isn't included in that first question, then you have to say, okay, well, if we add brown, yellow, red, blue, and orange together, it needs to equal 1.0. Well, the other way to kind of do that is to say, okay, we'll divide red, which is 1.3, by the base, which should be 1.0, but in this case it's 0.84. I hope that makes sense.
It does. No, it does make sense. So So 8, when we get the 0.154, we're rounding to the nearest 2 decimal spots. So
right, but it's 0.1547, so you carry the 7, which makes a 4 into
which
a
makes the
5.
4 5, which the 5 then makes the 6, right?
Yes.
Okay. So then my question on number 9, because it asks us to use the information to answer these 3 questions. When it says what is the probability that a randomly selected candy is green, wouldn't it be 0 since the green is taken out of the bag altogether, or no?
Well, but then if you say what's the probability that a randomly selected candy is not green, are you just going to do like 1.0 or just 1? So, I mean, I don't know. It would be really weird if that were the case.
So yeah, I guess my question is like, because I understand the 0.16 philosophy, but my question is this like a trick question saying what is the probability given this information that a randomly selected candy is green and rounded 2 decimal places? If the green is completely taken out of the bag of candy and we reach in, we're not going to have any greens, are we? That's my question. That's what I'm asking. Does that make sense?
Right. But yeah, I think the question is just worded pretty badly.
Oh, okay. Okay, so we'll
So I don't know.
six.
Well, one of us is going to put it in first, right? One of us is going to put the quiz in
Okay.
first, and then we'll go from there. So
Okay.
I'll
Okay,
go
I
first.
submitted it. We missed 2.
What's that?
We missed 2 of the selections.
What do you mean? The
So
green one?
I finished the quiz when you were explaining it. And so we missed question 8 and 9.
Really? Okay. So then I guess just leave green out of the whole thing. What did you put for number 10?
Oh, I messed up. So for question 8, I put 16. And then for question 9, I put 15.
Without the point? Like without
No,
the
I
dot?
put 0.16 and then 0.15 for question 9.
Oh, I see.
So I think it's 0.15 and then 0.16.
Okay, so switch those.
Yeah.
Okay.
All right, what did you get for
That's
10?
not very good rounding skills.
Yeah, I know, right?
What the heck? Okay.
The next one's so like we would have gotten question 10, right? I put 0.84, which is 1 minus 16%, which is the probability it's green.
Okay.
So
Why
it's
the heck did
0.84.
he ever
So
leave? I mean, that's just weird. Okay.
question 9 is 16.16.
Okay.
Okay. The ACT scores of students admitted to a medium-sized public university in the Western United States were taken from capex.com. The following summary statistics were calculated. Half of the observations are less than or equal to what number? So you just have to, the median, 24. Half of the observations are less than or equal to what number? It would be the median, wouldn't it?
It's the median, so it's 24.
Okay, that's what I thought. Okay, based on the information in the table above, the top 25% of students scored above what number? 27, right?
Sorry, I was just running through them.
The
Yeah,
top
it's 27.
25%. Okay. Which of the following statements is not one of the 3 rules of probability? One. It's the third one. If the probability is high, then the probability is positive. If the probability is low, then the probability is negative. That's not a rule. Okay.
All right, let's try it. Which one did I miss?
All right, what the heck? I still missed that one. It's not 0.15.
Mm-mm.
Maybe it's 0.13. Maybe we were just supposed to calculate it. Don't submit your second one yet, Darren.
Okay. So it's not 0.15?
No, you must have calculated it. Like we must have to calculate it right away, which is kind of pointless. That's dumb. I bet it's 0.13.
Okay.
I mean, because if we have to use green, if we calculated green and used it for question 9 and 10, then we must have had to use it for question 8 and calculated green right away. So it must be 0.13. That's the only other possibility I can come up with.
Okay, so I'll run through these. So true, true, true. 0.45.
Yep.
0.55.
Yep.
What is it? 0.143.
Yep.
Okay. Strong evidence to conclude that they can detect. We decided that 0.13 on the red, and we're keeping the 0.16 on the green.
0.84 on not green, 24, 27, and then if the probability is high, positive. If it's low, then negative.
Okay. Awesome. Great. Yeah, it was. It was just calculating it.
That's dumb. I mean,
Yeah,
whatever. I guess they. I don't know. I guess now it makes sense, but it's like a little frustrating.
Yeah.
Okay, I think I got it all. Let's hope I didn't misclick something.
It's always the worst.
So then, Darren, with the so I just gonna post like group 4, lesson 4.
Yep. And then you say like David Mann, Scott, Bartlett, and then Darren Fox.
Does my name say Scott Bartlett now in here?
Yep.
Yeah.
Perfect.
Is
Okay.
it 2T Scott on the last name?
Yes. Yes, it is.
Okay.
Cool.
All right, great. Perfect. Oh, Scott, I was telling Darren I won't be here Wednesday night. I'm going to be in Seattle. So if you
Okay,
guys want to
sweet.
start earlier or something like that, I'll just have to go through that one on my own kind of thing.
Okay. Wednesday night I can't remember. Didn't we change that to like 7 o'clock or something like that?
8.
Are we doing that at 7?
8, yeah.
8 o'clock. Okay.
Yeah.
I will